Forget everything you thought you knew about modern robotics. Humanoid robots are no longer just expensive science projects trapped inside climate-controlled research labs. We are witnessing the most aggressive hardware deployment in modern industrial history right now. Companies like Tesla, Figure, and Boston Dynamics are aggressively pushing synthetic humans onto literal factory floors. We are rapidly moving past carefully choreographed parkour videos and staged laboratory demos. We are entering the brutal era of pure, unstructured, real-world utility. Look at the recent active deployments in BMW automotive manufacturing plants. We are seeing bipedal robots actively manipulating heavy car parts directly alongside human workers. This is a massive paradigm shift happening in real time, right in front of our eyes. For decades, industrial robotic automation meant bolted-down robotic arms doing exactly one highly repetitive task. If you moved a metal bolt just 1 inch to the left, the million-dollar machine crashed. That old era of rigid, inflexible code is completely dead. The new generation of humanoids are fully autonomous, general-purpose synthetic workers. They perceive the messy physical world dynamically using advanced neural networks and spatial cameras. They correct their own physical mistakes and readjust their grip in seconds. This is the holy grail of physical automation, finally becoming a viable commercial reality. The deployment timeline is accelerating exponentially faster than any Wall Street analyst predicted. The commercial integration phase is no longer 10 years away. It is happening this exact calendar year. Get ready, because the physical economy is about to be completely rewritten. Let us break down the exact technology driving this sudden massive robotics explosion. There are two major hardware bottlenecks that engineers just solved simultaneously. First, we have the custom electric actuator revolution. Actuators are the artificial muscles and joints that give these massive machines fluid movement. Early sophisticated robots used bulky hydraulics that were heavy, dangerously slow, and prone to fluid leaking. Today, leading robotics companies are deploying advanced custom electric actuators. These new electric motors provide immense torque while maintaining astonishing millimeter-level precision. They mimic the exact power output and subtle flexibility of human biology. Second, we have finally breached the crucial battery density wall. You simply cannot have a useful humanoid worker if it needs to plug into a wall outlet every 20 minutes. High-density lithium battery packs integrated seamlessly into the robot torso now provide a full 8-hour work shift per charge. But physical hardware alone is just an empty, dead metal shell. The real breakthrough acting as the explosive catalyst is the artificial brain. Just 3 short years ago, software engineers had to write complex mathematical equations for a robot to simply balance on one foot. Now, these machines learn complex physical movement through advanced reinforcement learning algorithms. They are effectively tossed into high-fidelity physics simulations running on massive GPU clusters. Inside these accelerated digital environments, learn to walk, grab through millions of rapid trial-and-error iterations in mere hours. The highly successful neural weights are then downloaded directly into the physical robot brain. We are bypassing decades of tedious manual hard-coding literally overnight. This brings us directly to the actual full software architecture running inside these steel bodies. We are currently witnessing the absolute of traditional modular robotic programming. Previously, engineers built entirely separate software systems for computer vision, spatial navigation, and physical movement. That old approach was incredibly fragile and computationally expensive to maintain. Today, leading AI companies are deploying end-to-end neural networks locally on the edge hardware. This means the robot takes raw pixel data directly from its cameras and converts it instantly into motor control commands. There is no software middleman and no human-written logic standing in the way. It works exactly like the biological human brain, connecting your optical nerve directly to your muscle fibers. This is the exact same underlying architectural breakthrough that made generative AI explode globally. We took the foundational large language model framework and applied it directly to physical kinetics. Instead of predicting and generating text on a screen, the AI is generating fluid physical torque in real time. The revolutionary result is a robot that actually understands the complex semantics of its unstructured environment. If a heavy tool from its robotic hand, it does not freeze and trigger a fatal error code. It understands the conceptual physics of dropping an object, bends its knees, and dynamically picks it right back up. This deep semantic understanding of the chaotic physical world is the critical missing puzzle piece. It finally allows humanoid robots to successfully operate in messy environments built exclusively for human anatomy. The real-world massive economic impact of this physical AI technology is absolutely staggering. We are looking directly at a massive deflationary shock to physical manual labor across the entire globe. Think immediately about the global logistics and warehouse sectors first. These massive facilities struggle constantly with severe labor shortages and crushing worker turnover rates. The synthetic humanoid robot works 24 hours a day without physical fatigue, injury, or complaint. Perhaps most importantly, it does not require expensive custom infrastructure like automated conveyor belts or magnetic floor tracks. It can simply grab a standard human-sized pallet jack and start moving heavy inventory immediately. Furthermore, the unit economics of these machines are dropping aggressively fast. Tesla has publicly stated they aim to produce the Optimus robot for less than $20,000 at absolute scale. Compare that single hardware purchase to the massive cost of a human worker doing dull, repetitive assembly line tasks over 5 years. The rapid return on investment for major manufacturing companies is completely impossible to ignore. We are moving very quickly from software as a service to physical labor as a service. Major companies will soon lease synthetic workers by the literal hour to handle dangerous or dirty repetitive tasks safely. We will soon see a massive rapid reshoring of manufacturing supply chains back to domestic soil. When the core cost of factory labor drops near zero, it no longer makes economic sense to ship parts across the ocean. This single technology will rebuild local manufacturing capabilities from the ground up entirely. Commercial transition is happening rapidly from closed corporate labs to active factory floor testing. The next logical and inevitable phase is entering consumer retail spaces and eventually your own home. The underlying neural architecture scaling laws do not suddenly stop at dull industrial logistics. The exact same artificial muscles and neural pathways that sort heavy car parts today will soon be folding your laundry. The timeline for domestic humanoid integration is aggressively shrinking every major software update deployed over the air. We are actively watching the messy birth of an entirely new synthetic labor class. Technology companies successfully building and controlling these physical platforms will command market caps larger than modern nation-states. It is absolutely critical to stay informed because this physical hardware will drastically reshape your daily life. Do not let the massive robotic tech revolution catch you entirely off guard. You need to understand the real signal cutting through the massive hype and background noise. This is exactly what we deliver every single week right here at NeonSync AI. We provide the hard technical facts and deployment realities without the endless fluff. If you truly want to stay ahead of the rapid hardware curve, subscribe to the channel right now. Hit that notification bell so you never miss another crucial high-speed tech update. Drop a quick comment below telling us what daily task you would outsource to a humanoid robot first. Let us build the future together, 1 minute at a time. I will see you in the next high-speed technology breakdown.